Okay, so this is an extra review or extra practice for test number 1, which is 1-6, 1-7, 1-8. So the first problem I'm going to do is going to be 3x minus 2 squared equals 8. Okay, so everybody go ahead and try and see if you can solve this. Again, remember to leave it in simplest radical form. Okay, so for this one, this was back in 1-6. It was what you took the quiz on. So remember, we're going to apply the square root method here. And we are going to square root both sides. Then we get 3x minus 2 equals plus and minus the square root of 8. I now need to simplify my square root here because there's a perfect square hiding in here. I can simplify the square root of 8. 2 times 4, and this would become 2 radical 2. So 3x minus 2 equals plus or minus 2 radical 2. Add 2. 3x equals 2 plus or minus 2 radical 2, and then divide by 3. So x is equal to 2 plus or minus 2 radical 2 divided by 3. And you can leave it like that. There wasn't any graphing involved. It was just like that. Okay, so on tomorrow's test, you will not have to draw any graphs for me, but you will have to write all of your answers in interval notation for any of the inequalities. Now, remember from the 1-6 section, remember whenever your problem was a square root or if it was a fraction, remember you had to check for extraneous solutions. Again, if you find that time is a problem for you, I highly recommend you go through solve everything and then go back and check. Okay, so the instructions on the test are just going to say solve, check for extraneous solutions. Now, that's the main directions under everything, but keep in mind you don't have to check every problem. Also for the inequalities, it's going to say solve, write your answers in interval notation. Now, someone also asked me, can we have imaginary numbers in this? Yes, you can, because we've already covered the complex numbers. So anything goes. Anything we've learned since the beginning of the year can reappear. So just be aware of that. Let's try one. Let's try 2x to the 4th minus x squared equals 0. Give you a few minutes here. Okay, so for this one, notice it is not a trinomial. So what I'm going to do here is, remember, whenever you factor any question, you should always look for a greatest common factor first. So I'm going to pull a GCF out of x squared, and then I'm left with 2x squared minus 1 equals 0. Notice on this one, I can't factor what remained, so now I'm just going to set each factor equal to 0. So x squared equals 0, and then I'm going to set this one equal to 0. 2x squared minus 1 equals 0. Over here, when I square root this, I just get x equals 0. For the green one, I will add 1. 2x squared equals 1, divide by 2, x squared equals 1/2. Again, I need to apply the square root method here. So x equals plus and minus the square root of 1 over the square root of 2. Again, I can simplify this. I can't leave the 2 in the bottom, so I have to rationalize this. Multiply top and bottom by root 2. And I get plus and minus square root of 2 over 2. So my two solutions here are 0 and plus and minus square root 2 over 2. I don't need to check this. It's a polynomial. Let's go ahead and try another one. Everybody good on this one? I believe this was on your quiz, that question I just did. Let's try another one. Let's do x plus 4 times x plus 2 equals 2x. Solve for x. I'll give you a few minutes here. Okay, so for this one, I need to FOIL that left side, or multiply it, so I get x squared plus 2x plus 4x plus 8. I now need to combine my like terms and then move the 2x to the other side. X squared plus 6x plus 8. Now, if you would have realized you had a 2x and a 2x on both sides, you could have just canceled them, but I'm going to move it over. X squared plus 4x plus 8 equals 0. Now, at first glance, you might look and say, factors of 8, that give me 4. And you're thinking 1 times 8, 2 times 4. None of those are going to work. So I either have to do completing the square or quadratic formula. I can show you both. So let's do quadratic formula, because I know a lot of you like that. So my A is 1, my B is 4, my C is 8. So negative B plus or minus B squared minus 4 times A times C, all divided by 2 times A. Negative 4 plus or minus 16 minus 32. Negative 4 plus or minus the square root of negative 16. Do not try to simplify that 4 and 2 yet. We need to break down the radical first. Once I break down the negative 16, I get 4i. Now I can simplify, because this 2 needs to simplify with both. So then I'm left with negative 2 plus or minus 2i. I don't need to check that. It was a polynomial. Now, let's say you didn't want to do quadratic formula. You wanted to do completing the square. So if you did that, over here I'll do completing the square. So again, for completing the square, you need to take your constant, move it to the other side. Take the b term, divide it by 2, and square it. So I'll be adding 4 to both sides. Factor this side, and I get x plus 2 squared equals negative 4. I'm now going to square root both sides. X plus 2 equals plus and minus 2i. Move the 2 over, and x equals negative 2 plus or minus 2i. So I didn't have to simplify anything here. It went right to my answer. So for the test tomorrow, we were going to add a completing the square question. However, it will not be mandatory. If you do get a question where it can't be factored, you can choose. If you're more comfortable with quadratic formula, you can use that. However, you may get a question where it won't be able to be factored, and you're going to need to use one of these 2 techniques. Let me try an inequality this time. If we have time, we'll come back. Actually, let me do, I'll do an inequality first. 11x greater than or equal to 2 times x minus 4. Okay, so this was just a simple inequality from, I guess, 1-7a. So first thing I'm going to do is distribute. 11x greater than or equal to 2x minus 8. Then need to get my variables together. And I get 9x greater than or equal to negative 8. Divide by 9. And x is greater than or equal to 8 over 9. And again, on your number line, remember when it's greater than, it would be like, this one would be like a bracket going this way. So again, you could put your infinities on there if that helps you. So in interval notation, now On the test tomorrow, you won't have to show me this, but again, when you have to break up the intervals, you really need to do that for yourself. My thing that I'm going to grade on the line is just going to be in interval notation. You would write bracket, -8/9 to infinity. Remember, the infinity always gets a parentheses. So this was from 1-7A. Let's try a quadratic one from 1-7B. One from 1-7B. And this would be x squared plus 4x greater than 21. The first thing I'm going to do is turn it into an equation that's set equal to 0. So I'm going to subtract the 21. X squared plus 4x minus 21 equals 0. I now need to factor it to get my cutoff points that are going to break up my intervals. So my factors of -21, that will give me +4, are going to be x plus 7 and x minus 3. I now need to set each of these factors equal to 0. So I'm going to subtract 7. So x equals -7. Add 3. X equals +3. I now need to put it on my number line so I can see where my test point is going to be located. Again, I'm putting them on here, least to greatest. So again, I like to use 0 as my test point. Again, you can choose whatever number you want. So for me, 0 is going to be located here in the middle. So if I go back to my original problem, it was x squared plus 4x greater than 21. If I plug in 0, 0 squared, 4 times 0. Is 0 greater than 21? No, it's not. This gets an x. And then the check marks are on the edges. So remember, when the check marks are on the two sides, this is going to be the union situation. So again, if it helps you to see the -infinity and the positive, goes from -infinity to -7, unioned with 3 to infinity. Let's try that. 2x to the third minus 3x squared minus 5x less than 0. Solve and write your answer in interval notation. Okay, so again, I'm going to turn it into an equal sign. So 2x cubed minus 3x squared minus 5x equals 0. I always should look to see if I can factor out a greatest common factor. I can divide everything by x, and then I'm left with 2x squared minus 3x minus 5 equals 0. I now need to factor this trinomial. I'm going to guess and test. I'm going to try 2x minus 5 and x plus 1. Let me quick do a FOIL here. I get 2x, -5x. When I add them, I get -3, and everything else is good. Now, if you need to do the whole grouping, you can, but this was small enough where I could factor by grouping. Guess and test. So now I set each one of these factors equal to 0. So the x equals 0. Then I'm going to do the 2x minus 5 equals 0. 2x divide by 2. X equals 5/2. And then over here, last one, do it in red, this guy, x plus 1 equals 0. Subtract, x equals -1. Now, this time I'm going to be breaking up my number line into 4 sections. -infinity, positive infinity. So I have -1, 0, and 5/2. Notice this time 0 was one of my answers, so I can't use 0 as a test point. I'm going to go ahead and I'm going to plug in a 1. Pretty good on that? All right, so if I go back to my original, which was 2x cubed minus 3x squared minus 5x is less than 0. So 2 times 1 cubed minus 3 times 1 squared, 5 times 1. So here I get 2 minus 3 minus 5. 2 minus 3, negative 1. So negative 6, is that less than 0? Yes, it is. So this gets a check. X, and again, it's going to repeat. Do this in blue, and the X is in red. Okay, so now my interval notation is going to go from negative infinity up to the negative 1. Where this X is, I'm going to put a U, and then it picks up again from 0 to 5/2. And there's your interval notation. Let's try another one. A fraction, this was 1/7c. So 5x plus 2 over x less than negative 1. I need to make an equation and set it equal to 0. So I'm going to add 1 to both sides. 5x plus 2 over x plus 1 equals 0. I now need to find a common denominator, and it's going to be x. So I'm going to change this whole number 1 into x over x. This one's staying the same. And now I can add my numerator. So I get 5x plus 1x is 6x. And now for the fractions, when we solve these, we set each the numerator equal to 0 and the denominator. This is going to give me my cutoff points. So then here I will subtract 2. 6x equals negative 2. Divide by 6. And x equals negative 1/3. Need to bring this one down. So now I'll go ahead and put it on my number line. Negative 1/3 and 0. Again, I need to find a test point. I can't use 0, so let me plug in 1. 1's located over here. So my original problem was 5 plus 5x plus 2 over x less than negative 1. 5 times 1 plus 2 over 1. 7 over 1. Is 7 less than negative 1? No, it's not. It gets an x here, a check here, x here. So my solution here is just the middle. So negative 1/3 to 0. So just this section here. Yes. Okay, here's another example. This one will be a fraction. So 2 over x plus 2 plus 1 over x plus 4 equals 4 over x squared plus 6x plus 8. I'm going to factor the denominator here. This will factor into x plus 2, x plus 4. So I'm going to now multiply my entire equation by the common denominator, and that's going to be x plus 2 times x plus 4. When I distribute it to the first fraction is missing the x plus 4. The second fraction is missing the x plus 2. The last fraction has everything it needs. I'm now going to distribute to x plus 8 plus x plus 2 equals 4. Combine my like terms. Move the 10 over. Divide by 3. X equals negative 2. I now need to check this because this is a rational equation. So when I plug in x equals negative 2 to here or here, I do get a 0 in the denominator. So this is an extraneous solution. This one is out. So my solution here is no solution. The next one will be a radical equation. So I have 5x minus 15 minus x plus 1, all under the radical, equals 2. Remember, when you solve radical equations, your first step is to isolate one of the radicals. So I'm going to add the square root of x plus 1 to the other side. I now have 2 plus x plus 1 under the radical. In order to cancel the radical, I am going to square both sides. Squaring the left side causes that to cancel. I'm left with 5x minus 15. I'm going to FOIL this, 2 plus x plus 1 times 2 plus x plus 1. I get 4 plus 2 times x plus 1 plus 2 times x plus 1. And then when I do the last term, the radical just disappears. I'm going to combine some like terms here. I get 5 plus x plus 4 times x plus 1 under the radical. I'm now going to try to isolate this radical. So I'm going to move the 5 over by subtracting it. Then I'm going to move the x over. I now have 4x minus 20 is equal to 4 times x plus 1. I'm actually going to divide everything by 4, so my problem's not so huge. So then I get x minus 5 equals x plus 1. Now I'm going to square both sides to cancel the radical. This cancels, so I'm left with x plus 1. Over here I'm going to FOIL x squared minus 10x plus 25. I'm going to move the x. X squared minus 11x plus 25 equals 1. I'll move the 1. X squared minus 11x plus 24 equals 0. I'm going to factor this. X minus 3, x minus 8. Set each of the factors equal to 0. Add 3. X equals 3. Add 8. X equals 8. And again, this had a radical to begin with, so I do need to check it. So 5x minus 15 minus x plus 1 equals 2. I need to check both, so let me write it over here again so I can do the check for the other one also. So if I plug in 3, I get 15 minus 15. I get the square root is 0. Square root of 4 is 2. 0 minus 2 does not give me positive 2. It gives me negative 2. So x equals 3 is not a good solution. It would not give me a good answer. Let me go ahead and plug in 8. So 5 times 8 minus 15. 8 plus 1. 40 minus 15. 8 plus 1 is 9. 40 minus 15 is 25. Square root of 25 is 5. Square root of 9 is 3. 5 minus 3 is 2. It checks. So x equals 8 is my solution. It checks. Okay, let's try an absolute value inequality. So 5x minus 8 greater than or equal to 2. Again, when we have absolute value inequalities, our first step is to isolate the absolute value, and it's isolated. Now I'm going to set up my two inequalities to solve. So again, I would drop the absolute value bars, and then the second inequality, I reverse the symbol and make the answer negative. I'm going to add 8. 5x equals 10. Divide by 5, and x equals 2. Here I'll add 8. 5x is less than or equal to 6. Divide by 5, and x is less than or equal to 6/5. Let me go ahead and graph this. So I'm going to put it in order from least to greatest. So 6 over 5 is 1 1/5, so I'll put that to the left. And now I'll graph each one. So the first one, and let me change my symbol back here, this should be greater than or equal to. So this would be a closed circle on the 6/5, and it would be going, it's going to be going this way. And then when I graph the x is greater than or equal to 2, closed circle, going in this direction. So when I write this, again, remember negative infinities over here, positive here. So negative infinity up to the 6/5 with a bracket, unioned with 2 to infinity. Let's try one more absolute value. 7 minus 2x less than or equal to negative 2. Again, remember, whenever your absolute value is already isolated, if this number is negative, you need to stop and think. Think about it logically. Remember, what will come out of an absolute value will always be positive. So notice that there will never be a value of x that I can plug in here that would give me something that's less than a negative number. So when this occurs, the answer to this problem is no solution. Let's try one more question, and we'll do a U-substitution with it. So again, this is from 1/6. So if I have x plus 3 raised to the 2/3 power, x plus 3 to the 1/3 power minus 6 equals 0. When you're going to use the U-substitution, we're going to set u equal to the middle term. So u is going to be equal to x plus 3 raised to the 1/3 power. So now I'm going to replace, so this will be u. I'm going to write down the minus 6 equals 0. And then again, your first term will be u squared. So I'm looking for the factors of negative 6 that will give me 1 when I subtract them. And those factors are going to be positive 3 and negative 2. I now need to set them equal to 0. U plus 3 equals 0. U minus 2 equals 0. Subtract 3. U is equal to negative 3. Add 2. U is equal to 2. Again, the question did not ask me to solve for u. It wants me to find x. So now I'm going to take out these u's, and I'm going to put what I set u equal to, which was the x plus 3 to the 1/3 power. I'll write it on both of them. So now again, what we need to do here is get rid of that fraction exponent. So I'm going to raise both sides to the 3rd power. This becomes x plus 3 is equal to negative 27. Same thing over here. And I get x plus 3 equals 8, And now I'll solve each one. Subtract 3. X is equal to negative 30. Subtract 3 here, and x is equal to 5. So my two solutions are going to be negative 30 and positive 5. So again, the test will cover sections 1.6, 1.7, and 1.8. Remember that when you come to the quadratic, anytime you need to solve a quadratic equation, it doesn't matter how you solve it, especially in the non-factorable equations. You can either use completing the square or quadratic formula. If your quadratic equation can be factored, I highly recommend you use the factoring method. It is the fastest. However, again, you can use whatever you choose when it's non-factorable, either completing the square or quadratic formula. So the test is tomorrow. It will have 14 questions. Again, remember to work rapidly. Remember on the solve equations, remember to check your answers when it's an even root and when it's a fraction.